I want to take a little time and review the methods that we have for solving triangles. It's real important to kind of take a look at the information that you're given. When we're looking at this triangle, some things that jump out to me, like the most important thing that jumps out to me, is that we're given a right angle. Right? Anytime that we're given a right angle, we can use just the basic trig functions of sine, cosine, and tangent, or even Pythagorean theorem. In order to solve a triangle, the first thing you want to do is label all of the information that you have. In this case, we know that angle C is 90 degrees. I also know that angle B is 53 degrees. And side B is 36. In order to solve the triangle, we need to find all of the angles and all of the side lengths. So we have 3 more to go. First of all, if I'm going to find out what angle A is, we're going to start with the 180 degrees that make up all the angles that are in a triangle and subtract off the ones we know, like that 90 and that 53. When we do that sort of subtraction, we should end up with 37 degrees. Now we have 2 more sides to go. And since we have a right triangle, we can just use sine, cosine, or tangent. So thinking about this angle B and side B. Right, side B is its opposite. If I want to find out what side A is, I've got an angle, its opposite, and its adjacent sides. So opposite over adjacent is tangent. So I'm going to take the tangent of 53 degrees is equal to opposite over adjacent. Now we have an equation that we have to solve, so multiply both sides by A. And so we'll have A times the tangent of 53 is equal to 36. And divide by that tangent. When all the canceling is said and done, 36 divided by the tangent of 53 degrees is 27.1279. Remember, we're only going to go 3 decimal places, so 27.127 is good enough. If you wanted to round to 27.128, that's correct as well. Then we still need to find out the hypotenuse. We could do that using the Pythagorean theorem, or if you want to, another trig function. Recognizing that 36 is still our opposite side, and C now is the hypotenuse. It is sine of 53 degrees is opposite over the hypotenuse. So again, we can multiply both sides by C and divide by that sine. So we would have C is 36 divided by the sine of 53 degrees. Doing that sort of calculation, we should have C is equal to 45.076. Once we have all 6 measurements, we should really quickly check, make sure our largest angle is paired with our largest side, and our smallest angle is paired with our smallest side. That looks legit, so we're good to go. Recognizing that we have a special triangle can help these things go quickly. For instance, in this one, I see that angle C is obviously 90 degrees, and side C is 10. When we take a closer look, I notice we have these 2 hash marks here. That indicates that these 2 side lengths have the same measure, which means these 2 angles have the same measure as well. So we're dealing with one of them 45, 45, 90 triangles. Okay? Both A and B are going to have the same side lengths. And what we remember about our special 45, 45, 90 triangle is this relationship that if these are, whatever these are, the hypotenuse is going to be square root of 2 times as big as that is. Right? Well, I'm not given the side lengths, I'm given the hypotenuse and need to work backwards. So instead of going from the side and multiplying by square root of 2, I have to go from the hypotenuse and get back to the side length. So that's going to mean taking that 10 and dividing by the square root of 2. And that's how we'll get that x. If we wanted an exact answer for that, we would take that 10 square root of 2 and multiply numerator and denominator by square root of 2 over square root of 2 like that, leaving us with 10 root 2 over 2, which of course is 5 square root of 2. If we're going to go with decimals and going to 3 decimal places, that will end up being 7.071. And of course, side A and side B are the same. So this will be 7.071 as well. Writing down what we know about this triangle, we see that angle Q is 90 degrees, angle P is 60 degrees, and side P is 8. Real quickly, just subtracting 60 and 90 from 180, we see that we have a 30, 60, 90 triangle. And the ratios to remember about a 30, 60, 90 triangle is that if we start with the short side, the hypotenuse is twice as long, and the longer leg is square root of 3 times as long as that shortest side. In our diagram, we're given the longer leg, and we know that the longer leg is square root of 3 times larger than the shortest leg, r. That means we can write a quick little equation that this 8, the longer leg, is square root of 3 times larger than the shortest side, r. To solve, we'd divide both sides by square root of 3. And we can simplify and see that r is going to be 8 square root of 3 over 3. And if we went with the decimal for that, that means r would be 4.618. Of course, then to get to the hypotenuse, Q, going from the shorter side to the hypotenuse, we just need to double that side. So Q is going to be twice as big as r, or 16 square root of 3 over 3, which is 9.237. But what about when we don't have a right triangle and we don't have a special triangle like 30, 60, 90 or 45, 45, 90? Then we need to use either the law of sines or the law of cosines. And what's going to determine that? It's based off of what we're given. So first, check out what you're given. In this diagram, I can see that angle M is 38 degrees, side P is 20, and side N is 16. Now, what we're looking for is we have to ask ourselves, do we have a pair? And by a pair, I mean an angle and its opposite side. So for M, we don't have side M. For side N, we do not have its angle. And for side P, we don't have its angle either. So we don't have any pairs. What that means for us is that we need to use the law of cosines. I'm going to find the side length first. So using the law of cosines, remember it looks a lot like Pythagorean theorem, that m squared is going to be n squared plus p squared. And then we just have to subtract 2np cosine of m. So just plugging in all these values, 16 squared, 20 squared, minus 2 times 16 times 20, cosine of 38 degrees. When we type that all in the calculator, we get 151.673. Now that is not our side length. Remember, that is m squared. So we need to take the square root of both sides, and we'll get m to be about equal to 12.315. Once we have that pair, now we can switch over to the law of sines. We know that the sine of 38 is related to 12.315 in the same way that the sine of n is related to 16. So if we multiply both sides by 16, we'll get that the sine of n is 0.7998, and n will be the inverse sine of that. And when we calculate that, we'll get it to be about equal to 53.034. degrees. Finally, the last thing is to find the last angle. Once we know two of them, we just subtract them from 180. So 180 minus the 38 and minus the 53.034, and we get 88.966 degrees. Our largest angle is paired with our largest side, smallest angle with our smallest side. So there is our solution. Let's go with one more. First thing, identify what you know. Angle X is 120 degrees. Side X is 30. And side Y is 10. When we're determining which law we should use, we look to see if we have a pair first. And I do have this angle and its opposite side. That means we're going to use law of sines. That being sine of 120 is related to 30 in the same way that the sine of y is related to 10. So we go ahead and multiply both sides of the equation by 10, and we'll get that sine y is equal to 0.28867. So y is the inverse sine of that 0.288, which is 16.778 degrees. So we can calculate that third angle by subtracting from 180. So z is going to be 180 minus the 120 degrees, and that 16.778 degrees leaves us with 43.222. Which we can use in the law of sines to find a side z. So again, we start with the sine of 120 degrees is 230 in the same way that the sine of 43.222 is to side z. This one's going to take a little bit more work to solve because we're going to have to cross multiply first. So z times sine of 120 is equal to 30 times the sine of 43.222 degrees. Then we have to divide both sides by that sine of 120 to get z alone. When we calculate all of that, we'll get that z is 23.723. And nothing else to do. That's not an angle measure or anything like that. So we check the longest side is paired with the longest angle and the shortest side paired with the shortest angle. So there is our solution. All right, so when you're given a triangle to solve, you kind of have this checklist that you want to go through. First, you check to see if it's a right triangle. Right triangles are sweet because then you can just use SOHCAHTOA, sine, cosine, and tangent to set up an equation and solve it that way. Maybe you get lucky and you're given a special triangle. And so those are your 30-60-90s and your 45-45 90s. So just remembering those, the ratio of the sides can help you there. Otherwise, you're going to have to use either law of sines or law of cosines. And the main thing is to check and see if you have a pair. If you have an angle and its opposite side, then you have a pair. And when you have a pair, you can use the law of sines. If you don't, then you have to use the law of cosines. And that kind of gives you a framework of how you can attack any given triangle problem.